JEE Main 2026, 4th April Shift 2, Physics, Question 35. A uniform disk of radius r and mass m is pivoted at point A on its rim. The disk hangs freely and can oscillate about this pivot for small angular displacements. Let us visualize this physical pendulum setup. A uniform disk of radius r and mass m is free to oscillate about axis A on the rim. For small oscillations, the time period is. The options are 2 pi root of 5r over 4g, 2 pi root of 2r over 3g, 2 pi root of 3r over 2g, or 2 pi root of 3r over g. Key concept: physical or compound pendulum. The time period of a rigid body oscillating about a pivot is t equals 2 pi times the square root of I over mgh, where I is the moment of inertia about the pivot and h is the distance from pivot to the center of mass. We use the parallel axis theorem to find I about the rim point. Step 1. Moment of inertia of a disk about its center is mr squared over 2. The pivot A is on the rim at distance r from the center. By parallel axis theorem, I about A equals mr squared over 2 plus mr squared, which gives 3mr squared over 2. Step 2. The distance from pivot A to the center of mass is h equals r. Substituting into the time period formula, t equals 2 pi times root of 3mr squared over 2 divided by mgr. The mass m cancels, giving t equals 2 pi times root of 3r over 2g. The correct answer is option 3, t equals 2 pi root of 3r over 2g. Exam tip: for physical pendulum problems, always remember the formula t equals 2 pi root of I over mgh. The most common disk MOI values to remember are: about center is half mr squared, about diameter is 1/4 mr squared, and about a tangent perpendicular to the plane is 3/2 mr squared. Like and subscribe for more JEE Main solutions at MAGPIEHUB.